It's no secret that we live in a world where AI is advancing faster than ever. Daily, basically. This causes significant challenges for organizations and individuals who struggle not only to stay ahead of the risks, but also to know what those risks are and what new ones have emerged since yesterday. It is a never-ending contest to protect the data, the systems, and even the AI models themselves from falling into the wrong hands and being exploited for the wrong purposes. We need an inside look at the new front lines of cybersecurity, from the threats we're already seeing, to the technologies that are reshaping defense strategies, to the hidden risks that could catch companies off guard. And I have just the team to provide this perspective. I'm Steve Prentice, and this is the Thales Security Sessions podcast. To help us take stock of the enormous revolution collectively called AI, I have three of the top data security specialists at Thales here with me today, and I will first pause to have each of them introduce themselves.
My name is Michael Zunke. I'm a CTO of software monetization. Everybody calls me by a nickname Mitsu. I'm based in Munich, always involved in new technologies, talking a lot with customers, partners, and also internally with product management and engineering.
Hi, my name is Nadav Vital, Senior Director of Threat Research in Imperva. I work closely with the product team, dev team, also customers to see how we can provide threat intelligence insights into our solutions to customers.
So I'm Asad Ali, Director of Technology for CSP, based out of the office in Austin.
Asad, to kick us off, can you explain the role of AI and how that connects to protecting data throughout its life cycle?
So AI is a general terms about different technologies, machine learning, which is how to learn from data. A specialized form of machine learning could be deep learning, where we are using the artificial neural networks to mimic the workings of the human brain. We go a little bit further, and now we have generative AI, which is you are training in such a way that the output is somehow consistent with what you had trained the data on. So you train it on the plays of Shakespeare, and out comes something which looks like in the Shakespearean style. The language is the same. So that's your generative AI. And then the LLMs, the large language models, it's a specialization which is made popular by the advances that we have had in the natural language processing. So instead of having an application talk to another application through an API or some other means, you now have a human that is typing at the screen and basically asking a question as if you were having a conversation with somebody who's sitting across the table. And all of those things have come together because of the two things that we have seen in the industry. One is the exponential growth of the compute power, and the second is access to and availability of large volumes of data.
What would be some examples of these different attack vectors?
So simplistically, if you were to divide up AI into, let's say, 4 phases, the first phase would be your collection phase, where we are collecting the data. That could be data which is coming from internal to an organization, from outside the organization, and that data could be poisoned. You move a little bit further, and now you're talking about training of a model with the data that you've collected. And the same attack vector of the data poisoning still exists, but now you have an additional one where the model itself could be poisoned. So this is what we generally refer to as the backdoor insertion, where you are modifying the behavior of the model based upon some changes that you've done. Moving along a step further, now you're in the deployment phase, where the model has been created, it has been deployed and put in a server somewhere where it can be used. Now, the attack surface is again different because now the environment has changed. I mean, previously it was in a silo or where it was being developed. Now it's out into the open. And in this case, you could have the model theft. And when the model theft happened, now the people who are responsible for the operations of an organization, how it is deployed, how it is protected, they would be interested in this. And then finally, when we go to the stage where the users are actually using it, so this is what we refer to generally as the inference stage, where the users are giving their prompts. Again, we're going back to the generative AI and the LLM use case. If the users intend to use it, they would give a prompt. The prompt would go back to the model would work on it. Certain data would be accessed. In case it's a RAG environment, you would access some databases, and out comes a response which is now given back to the user. If the model is poisoned to begin with, or some changes are happening over here, what is given back to the user could be detrimental to the data protection and security of the company. So, for instance, information could leak out, and this is where the CISOs would get involved.
And why does data become so crucial in these scenarios?
Because you are manipulating data, you are working with data, you're asking for information from the user, which is the data, and you're giving back information to the user, which is the results of a model's output, which is also data. And since we protect the data, we can also protect the use of data in AI. And indirectly and directly, in most cases, we can protect AI. We cannot claim that we protect all paths to AI, just like we do for data, but at least we can protect most of the paths to AI, and especially the ones which work with data.
Nadav, how are cyber attackers using generative AI to bypass traditional security controls and launch new kinds of attacks?
The thing with Gen AI, like any new technology, it provides new tools for attackers. So a few examples for that. Attackers are using AI to bypass security control. So a few examples could be malware written by AI, phishing emails written by AI, deepfakes, and all sorts of attacks that required very specific knowledge in the past that are now becoming easier to create using Gen AI tools. Second thing is that now we can use AI, or attackers can use AI to automate the attack process if people are unaware of this. So it begins with mapping or probing the target systems, mapping all the different technologies, trying to find the vulnerabilities, exploit them, then post-exploit the vulnerabilities to gather maximum impact. So this is a very lengthy process, and usually it's being done manually. And now there are tools driven by AI that can help attackers to automate this whole process and mimic a real world attacker very easily. The third thing the AI can enable for attackers is using this technology, using AI technology to discover new vulnerabilities. So we're talking about the zero-day vulnerabilities. And in the past few months, for example, Google discovered using AI a zero-day in a very popular project named SQLite. It's a database engine, a very popular database engine in use in many products in the world. So they used a specific model to go through the code of the project, analyze it, and find this hidden vulnerability that was there for I don't know how many years. So you can just imagine, the impact if attackers are now starting to deploy this on a mass scale and getting to this new vulnerability, to this new 0 days that no one knows about. So I think the overall trend, looking at these 3 points, using AI to bypass existing security control, using AI to automate the attack process, and using AI to discover zero-day vulnerabilities, the underlying trend here is that AI is lowering the bar for unskilled attackers and overload defenders with much more attacks that they need to deal with. So if we're talking about the impact of AI on the attack landscape, this is it.
But what about the other side, Nadav, our side? How are defenders starting to use AI to better detect threats and lighten the load for security teams?
Again, like any technology, AI can not only be used by attackers, but also by defenders. So I'll start with the last example that I gave. Detect unknown threats, 0 days. Like I said, in the example, Google found the last 0 day. So it went through the process of responsible disclosure and we're good. This is how it's supposed to be done. So if organizations or defenders will deploy AI to try to find these vulnerabilities before attackers do, that's a good thing. Also, AI can be used by defenders to reduce the number of alerts or the alert fatigue by filtering out noise and false positive, because AI can really help in reasoning, reporting, and forensics by allowing less skilled people to use natural language and dive into complex security issues. And the third thing that AI can help defenders is continuously learn and adapt to the threat landscape, which is very dynamic. So these three things are really, and especially the second thing is really game changers for defenders. And for specifically example for the second point that I made, how AI can reduce the number of alerts that security teams need to deal with. So we have a few examples from the Imperva product line. So we have explainability model where people that operate the web application firewall can just click on any security event to get simple human readable explanation about the security event that happened, why it happened, what's the malicious part that was flagged, how they can prevent it from happening again, and so on. And another thing that we're working on is the application security chatbot, where you can actually converse with the chatbot and ask complex questions and do this kind of reporting and forensic investigations in human language. You don't need to learn the entire API or the entire documentation of the product to do what you want to do.
And now a question from Michael Zenka, better known as Mitsu. When companies deploy AI-powered applications, what new challenges do they face around protecting intellectual property and system integrity?
I think when we're putting ourselves in the shoes of a company that has developed a service or an application that makes use of machine learning, of AI, we also have to really look at the breadth that they are operating in there. There's a lot of different ways of how deployment can actually be looking like. It could be deployed as a service where, for example, the one who has developed the service has pretty good control over it. So he is actually controlling the environment. He can make sure who can access it, all of these things, who can access the pods, the data itself, and everything there. But it goes actually up to deployments where they have very, very little control. It could be that it is going through, I don't know, a remote cloud that actually is a private cloud of the customer. So the software developer himself has much less control over this. Or if it goes to actually devices which are maybe used somewhere. Just think about autonomous driving. Yeah, the car is a device. The machine learning model will be running there. It will not be running in the cloud. Yeah, because of latency, because of obviously you have to make sure that it's available and all of these things. But also it could be simply on an open machine, simply on your normal PC. Also an application could be deployed with a machine learning model. So the threat vectors are looking very different. So the surface that you have there that attackers can be using is very different from the service. It's basically the service interface. If it is actually on your machine, basically they can take it apart as much as they want because they are the master on the machine. So when you have now here in mind that the company has invested a lot to actually develop this model, they are very interested in to having the control over it. And this is multiple dimensions. From the classic licensing perspective, it is that I want to make sure that I get paid for what I have delivered there. So from the value that I have delivered there that is used from my service or my application that I'm providing there, that I want to get my share of it. But also it is not only this, it is also about protecting the IP that I have there. I've invested a lot in the data, curating the data, and all of these things, training the model, testing it. And I don't want that a competitor can simply steal the model, use it himself, plug it into his application, and provide equal service quality. So it's really that there is much more to look at, but it doesn't stop there. It even goes further because when I'm delivering a model which is important, which is not just suggesting which article I should be reading or which additional thing I should be buying, if it is something that maybe is life critical or critical for my health or something like that, I also have to care about really the integrity of the whole system. I have to make sure that the model behaves like it should so that nobody can actually tamper the model. But it doesn't only stop at the model. It actually goes there if I've deployed something. The model is not running it itself. It's typically integrated into an application. There is data coming in there. You want to make sure that really the right data reaches to the model. The model itself does the right data processing. The model reports some results out of that. You want to make sure that these results are also represented correctly. So it's not only the integrity of the model, it's the integrity of the whole application, of the whole service. So this is really going much beyond plain model security. It goes really across the whole system that you're delivering there. There are various attacks that somehow trying to address it, and you have countermeasures to actually make this difficult for an attacker. For example, if he cannot really look at the model, understand how the model is working, change the model, or place another model somehow there in the application, you are preventing that somebody is modifying the model and you have an illegitimate behavior or wrong behavior of the model. Also, when you are protecting the integrity of the application, you can make sure that the data is really integer from receiving up to processing in the model, from receiving from the model up to it is really displayed there. So really this protection against reverse engineering, against analysis, against modification of the application, and protecting the model against further fine-tuning, modifying of weights, and all of this is really helping you to make sure you can deliver a reliable system.
Asad, going back to you for a moment, given how fast AI and generative AI are evolving, how is Thales adapting its approach to stay ahead and to help protect AI systems?
Stephen, in this question, I think it's interesting because, yes, I mean, the field of AI and generative AI in particular, I mean, it is advancing at a lightning speed. And by the way, so is that perception about the risks that it imposes. So I think from that point of view, not only people are using it, but they're finding that they need help protecting it. So the question is that, well, what can Thales do? To begin with, I mean, we have in our toolbox everything which is needed. So we talked about the protection of data. Mitsu has talked about the protection of the model itself through the licensing mechanism, whether it's on the server, whether it's on the edge. One thing that we have not talked about is the identity and access management. So that's another area which is needed, that, well, do you have the access to the data? Do you have access to use the model? Once you talk about retrieval augmented space, well, do you have right to access the database to which the additional information is available? And when you put it all together, there are very few companies that can claim that they can protect AI the way Thales can. Because not only do we have expertise in AI, we have expertise in protection of data, in protection of identity, protection of the applications themselves. There are a few things which certainly we are looking at, because as you said, I mean, the field is not static. So yes, we are looking at how to protect the RAG implementations. There are certain POCs which are already in play. We are also applying that to the world of data discovery and classification, and to see how we can protect there. Searchable encryption is another topic which is of interest to us, because that can come in handy. And as Mitsu was saying earlier, well, once the model is on the edge, how do you know that it is protected? On the server side, you have full control of the environment. You can have physical restrictions on who can access. In the edge environment, well, those restrictions are out of the window. Anybody who wants to have their hands on the device, they can, which means that they can have physical access to any tampering that they want to do. They have more information to do that. And then finally, the agentic AI, where the models actually take on an identity of their own. Either they are impersonating somebody or they are acting on somebody's behalf. So this is where our identity and access management expertise would come in. Finally, there are certain products that we have where we hook at the IO level. So the Cipher Trust transparent encryption is one product where we encrypt everything that touches the IO layer of an OS. And that IO layer we handle through the CPUs. Now, in the case of the AI models, we are using GPUs. So any changes that would happen there, where instead of loading the data through a CPU, then transferring it to the GPU through a bounce buffer, if the GPU can access the IO layer directly, then we would have to change our models or implementations. And that is something that we have actively started looking into. Even though it's not mainstream right now, we are thinking ahead and adapting our products so we can be in a good position to change or adapt.
Mitsu, you touched on healthcare earlier. Can you walk us through why securing AI deployments in medical applications is especially critical?
So when we look at the customers that are actually using the technology there's a lot of use actually in the medical space. Just think about companies that are making an application which actually analyzes an MR image if there's cancer actually detected. So really helping the doctors there. So really deploying this in the field is very important in a secure manner, because on the one side, they are having very flexible business models. They are often charging actually per execution, so really outcome based. Somehow, if cancer was detected, that might even result in different charging. And the really here staying ahead of the competition is very important. So really the IP protection is equally important for these customers. So to make this implementation very easy for our customers, we are having automatic tools that help them to take their already working application and apply our tools, and then we will encrypt the model itself so that it is sitting there encrypted. The application itself will automatically be instrumented that when it is accessing the model, is actually pulling it in and decrypting it. And all of this is only possible with the right licenses there, so you really can safely plug in the right license model, the right charging, how they want to do it with their customers there. And this is done with a Sentinel technology. Sentinel LDK is the licensing framework, and Sentinel Envelope is basically the technology which helps you to do these automatic implementations here.
Nadav, with large language models creating new risks, why do we need an AI firewall? And how could it become a must-have for future deployments?
We must have something like an AI firewall if we want to deploy LLMs safely at scale. A traditional web application firewall protects web application usually using security rules or static security rules to prevent stuff like SQL injection, cross-site scripting, code injection, and so on. But Gen AI introduces new kind of attack surface, which is the language. And actually, WASP organization issued a whole new category of risks dedicated specifically for LLM and Gen AI. And that means that we need defense mechanism that can understand the context, the intent, the semantics, and this is where AI firewall comes in. So you can think about it as a contextual security layer if you want to defend against those new type of attacks. To name a few, it's prompt injection, supply chain vulnerabilities, overusage of LLM calls, and so on. So we're working toward creating such a solution for our customers. And the second part of the question, could it evolve to become a default layer in all AI-powered applications? So I'd say definitely. I think the sooner that we'll have these kind of security solution in place, the more people will learn to trust and use AI more safely in scale.
Mitsu, do you see it the same way, that defense tools will need to operate at a much deeper semantic level to truly protect AI-powered systems?
I think that makes tons of sense, because if you somehow think about like antivirus protection, pattern recognition somehow is a simple thing there. But if you really want to discover something that is more related to the creativity that is there, you will have to do analysis what's really going on there. And for that you have to go to the same level like you are communicating with the system that you are attacking. It is not an API anymore where it's very structured what you're actually doing. Well, there you had buffer overruns and things like that, but now it is really the semantics there. And as long as you don't get to the same level in defense, you will not have a real chance. Totally agree.
And now we get to our last question. Assad, how are companies' perceptions of AI risks shifting? And what does that tell us about where AI security is headed?
AI is moving very quickly, but so is the perception about the risks that it poses. Because initially it was something which was nice to have. People were enamored by what it can do, but they did not realize that, well, what are some of the pitfalls that can happen? And we've seen that evolve very, very quickly. When we talk to our customers, we've seen that perception change in just a few months. So that's something to keep in mind, that people know what the risks are, they have realized that, and they are looking for solutions.
Well, as this conversation makes clear, the rise of AI is opening new possibilities and new risks at every level of business and technology. Protecting data, protecting models, and protecting the trust that users place in these systems is no longer optional. Of course, it is essential. So I want to thank Assad Ali, Director of Technology for CSP at Thales.
Thank you, Steve. It was a pleasure.
Nadav Avital, Senior Director of Threat Research at Imperva, a Thales company.
Thank you, Steve. Thank you for having me. It was a pleasure.
And Michael Zunke, also known as Mitsu, CTO of Software Modernization at Thales, for sharing your insights today.
Thank you very much for having me. It was interesting to actually talk with everybody about the threats which are there.
Remember, if you like what you hear, be sure to subscribe and tell a friend or a colleague or a client or your favorite AI chatbot about the Thales Security Sessions podcast. We will be back again soon with another episode and another discussion on the topics that you need to know about to successfully carry on in the business of information security. Until then, I'm Steve Prentice. Thanks for listening.